Full load amperage, or FLA, according to NFPA 79 and the National Electrical Code, is the maximum current that an electrical device or circuit is expected to draw under normal operating conditions. It's used to size conductors, overcurrent protection devices, and other equipment in electrical systems. Consider a heater divided into 6 separate zones, each individually SCR controlled with 0 cross-firing. The power is supplied by a transformer. For a fast ramp up, 100% power is applied to the zones, drawing a maximum current of approximately 146 amps. After about 10 to 15 minutes, the power reduces to between 20 to 30% of the maximum current to prevent overshoot. And after 1 hour, the power increases to 80% of the maximum current for a specific process step lasting approximately 5 minutes. The current is extremely fluctuating. The question is, what is the FLA in this circuit according to the definition? In cable dimension calculations, should you use the 146 amps, or is it permissible to consider the current as discontinuous? The maximum current is 146 amps. The current after 10 to 15 minutes is 20 to 30% of 146 amps, resulting in 29 to 44 amps. The current after 1 hour for 5 minutes is 80% of 146 amps, resulting in 117 amps. According to NEC 310.15, 310.16, and 310.17, you cannot simply use the maximum current, 146 amps, as the FLA. You must consider the continuous load or discontinuous load nature of the circuit. A continuous load is defined as a load that operates at its maximum current for 3 hours or more. A discontinuous load operates at its maximum current for less than 3 hours. In the example, the load is discontinuous because it operates at a reduced current after 10 to 15 minutes and only for 5 minutes at 80% current. For discontinuous loads, NEC Table 310.15b16 applies. This table provides allowable ampacities for conductors based on the maximum current, not the full load amperage. To select the correct cable size, firstly, use the maximum current, 146 amps, as the allowable ampacity value from Table 310.15b16. Secondly, for 105 degrees Celsius conductors, such as a 2/0 American wire gauge, the allowable ampacity for discontinuous loads is 140 amps. Therefore, a 2/0 American wire gauge cable is not quite acceptable for your circuit in the scenario, since 140 amps is less than the required 146 amps. A larger conductor with an ampacity rating of at least 146 amps at the given temperature rating must be used. The fuse rating should be equal to or greater than the maximum current. A 160 amp fuse is acceptable. The FLA for the circuit is less than the maximum current of 146 amps. However, because of the discontinuous load nature, you should use the maximum current of 146 amps in cable sizing calculations. A 2/0 American wire gauge cable with a 105 degrees Celsius insulation rating is not acceptable. You will need to use a larger cable with a higher ampacity rating than 146 amps for the given conditions. A 160 amp fuse is appropriate for the circuit protection. In summary, accurately determining the nature of the load, whether continuous or discontinuous, is critical for proper conductor sizing and overcurrent protection. When dealing with discontinuous loads that have significant fluctuations, it's essential to base calculations on the maximum expected current rather than attempting to determine a single full load amperage value. Consult NEC Table 310.15b16 and other relevant sections to ensure code compliance and safe operation of the electrical system. Always consider the temperature rating of the conductors and choose a cable size with an ampacity that meets or exceeds the requirements.